Welcome to the Sleepy Astronomer, where we explore the quiet wonders of the universe, one stardust particle at a time. Before we begin, I'd love to know, where in the world are you watching from tonight? Whether you're lying under the stars, wrapped in a cozy blanket, or drifting towards sleep, let's take a peaceful journey through space together. Tonight's topic: cosmic dust. Tiny, ancient, and full of secrets, these specks tell the story of our universe in the gentlest way. Cosmic dust may sound like something out of a dream, or a story whispered under the stars, but it's a very real part of our universe. In fact, it's everywhere. Floating between stars, drifting through galaxies, gently raining down on planets, including our own. These tiny particles, often smaller than a grain of sand, are some of the oldest, most mysterious travellers in the cosmos. They're not like the dust you find on a bookshelf or in the corners of a quiet room. No, cosmic dust is far more ancient and sacred. It's made of tiny, solid particles, mostly silicates, carbon, ice, and metals. Though individually microscopic, together these particles create massive structures in space, clouds, nebulae, and even the raw material from which stars and planets are born. Imagine for a moment a single particle of dust drifting through the black silence of space. It may have formed in the outer layers of an exploding star, a supernova, or in the soft winds of a dying red giant. It could have begun its journey billions of years ago, before our sun even existed. And since then, it has floated, sometimes for eons, pushed by starlight, pulled by gravity, occasionally colliding with other particles, and slowly becoming part of something larger. Despite its small size, cosmic dust plays a big role in the universe. When large clouds of this dust gather together, they can block the light of distant stars. These dark clouds, which look like empty patches in the night sky, are actually full of potential. Over time, the dust within them clumps together. The particles begin to stick, forming pebbles, then rocks, then planetesimals, the building blocks of planets. Without cosmic dust, there would be no Earth, no Moon, no us. Astronomers used to see these dusty regions as annoyances because they obscured their view of stars and galaxies. But as technology improved, and as we learned to observe space using infrared light, we discovered that these clouds weren't just in the way, they were essential. They were hiding the secrets of star formation. They were glowing faintly in the infrared, revealing places where new stars and planets were being born. Cosmic dust isn't just in distant galaxies or floating around newborn stars. It's closer than you might think. Every day, Earth collects over 100 tons of space dust. It falls through the atmosphere, sometimes glowing as tiny meteors, those soft streaks you might see on a quiet night. Other times it drifts down invisibly, settling into oceans, deserts, and mountaintops. Some of the dust you see on a windowsill may have travelled through space for millions of years before gently landing there, unnoticed. And even now, this dust continues its silent journey. In the vast, cold reaches between stars and planets, it drifts, alone, timeless, and barely touched by anything but light. It carries with it a memory of the stars that birthed it, a trace of the explosive death of suns, a whisper of the early universe, still echoing in its ancient form. To look at cosmic dust is to look at the beginning of everything. It is the universe's quiet storyteller, tiny, unassuming, and full of history. It reminds us that even the smallest things can carry the weight of galaxies, and that even in the emptiest spaces, there is something softly floating, waiting to be seen, to be understood, or simply to be wondered at. As we drift deeper into this gentle journey together, remember, every star, every planet, and even we ourselves began with dust. Cosmic dust isn't just scattered randomly throughout the universe. It has a distinct and ever-present role within our own solar system. Though space may seem like a vast, empty void, it is actually alive with motion, filled with countless particles of dust, moving in graceful, invisible patterns. These particles, though minuscule and often overlooked, weave a delicate web that connects planets, moons, asteroids and comets in a silent cosmic dance. Much of the dust in our solar system comes from ancient origins, leftovers from the cloud of gas and dust that gave birth to the Sun and the planets more than 4.5 billion years ago. Some of it formed from the erosion of asteroids as they collide, grind, and fragment over time. Other particles come from comets, which release dust and gas as they pass close to the Sun. As these icy bodies heat up, they shed material in glowing tails that trail behind them, like glitter cast into the solar wind. This ongoing release of dust forms a subtle but ever-changing structure, known as the zodiacal cloud. If you've ever been lucky enough to watch the sky from a very dark location just before sunrise or just after sunset, you may have seen a faint, triangular glow stretching upward along the horizon. That glow is caused by sunlight scattering off dust particles in the zodiacal cloud. It's a quiet, visual reminder that space, even close to home, is full of fine debris left behind by moving celestial bodies. But this dust isn't stationary. It's always on the move. Pulled gently by the sun's gravity and pushed outward by the faint pressure of sunlight, each grain slowly spirals inward over thousands or even millions of years. Some particles eventually fall into the sun. Others may be captured by the gravity of planets like Earth, where they drift down through the atmosphere as micrometeorites, landing softly on rooftops, forests, oceans, and even in our drinking water. Scientists have found cosmic dust in places as remote as the polar ice caps and as familiar as city gutters. And not all of this dust is the same. Some particles are carbon-rich, dark and organic, perhaps containing the building blocks of life. Others are made of silicates, tiny crystal-like structures that glimmer in the right light. Each one tells a slightly different story of where it came from, how it formed, and how long it's been travelling through space. The giant planets of our solar system, like Jupiter and Saturn, also have their part to play. Their powerful gravity can trap dust into rings or fling it away into deep space. The rings of Saturn, for example, are not only made of ice and rock, but also laced with fine dust. This dust scatters sunlight in soft glowing halos, creating some of the most beautiful sights in the solar system. Even moons interact with dust. Saturn's moon Enceladus, for example, sprays out icy particles from beneath its frozen surface through towering geysers. These particles add new material to Saturn's outermost ring, creating a delicate cycle of renewal. Meanwhile, the Moon, our own natural satellite, is constantly bombarded by space dust. which has slowly created a surface covered in fine, glassy grains called regolith. Every step an astronaut took during the Apollo missions kicked up clouds of this sharp, gritty dust that had been accumulating for billions of years. Cosmic dust even influences spacecraft. As they travel through the solar system, they pass through fields of these tiny particles. Some missions, like NASA's Stardust spacecraft, were designed specifically to capture cosmic dust and return it to Earth, sealed in tiny collectors made of aerogel, a material so light and delicate that it can trap a high-speed particle without destroying it. When scientists examined these captured grains under microscopes, they saw the signatures of other stars, proof that some dust in our solar system may have drifted here from far beyond. Even today, the solar system remains full of unseen dust streams. Earth itself orbits through several of them each year. When our planet crosses the dusty trails left behind by old comets, the particles hit our atmosphere and burn up, creating meteor showers. These gentle rainfalls of light, the Perseids, the Leonids, the Geminids, are celestial reminders that the solar system is always shedding, always moving, always giving us brief glimpses of something greater than ourselves. So when we look up at the night sky, and think of stars and planets, we might also remember the dust. The ancient, silent, drifting particles that float through the solar system, shaping rings, glowing in sunlight, and sometimes falling into our very hands. They may be small, but they are part of the great unfolding story of the cosmos. And they are always with us. In the sky, above and beneath our feet, whispers of space, resting softly on our world. In the grand story of the universe, there is a quiet and solemn chapter that tells us where cosmic dust is born, not in places of calm, but in places of awe-inspiring endings. The birthplace of dust is not a nursery, but a star's final breath. It is in the death of stars, those brilliant, fiery giants of the cosmos, that the seeds of new creation are scattered. To understand how dust is born, we must travel to the end of a star's life. Stars, like all living things, have lifespans. They begin as clouds of gas and dust themselves, slowly collapsing under their own gravity until nuclear fusion ignites their cores. For millions or even billions of years, they shine, converting hydrogen into helium and releasing light and energy into the universe. But eventually, their fuel runs out. And it is in these final stages, this twilight of a star's life, that something miraculous happens. There are two primary types of dying stars that give birth to dust: red giants and supernovae. Let's start with the red giants. When a star like our Sun reaches the end of its main sequence life, it expands into a red giant. Its outer layers swell to many times their original size, and the core begins to fuse heavier elements like carbon and oxygen. As the star pulses, it begins to shed its outer layers into space. These layers are rich with newly forged elements and molecules: carbon, silicon, oxygen, and iron, all drifting outward in gentle stellar winds. Over time, the material cools and condenses, forming solid particles of dust. These grains begin their journey outward into the interstellar medium, carrying the legacy of the star that birthed them. Each tiny particle is like a time capsule, a silent record of the complex fusion processes that took place deep within a star. A particle may be made of graphite, or silicate, or some more exotic crystalline form. But regardless of composition, all of them began as stardust, fragments of a sun's final gift to the cosmos. But not all stars go quietly. Some die in fire. When a massive star reaches the end of its life, it can no longer support itself against gravity. Its core collapses in a violent instant, and the outer layers are expelled in a spectacular explosion known as a supernova. This explosion is one of the most powerful events in the universe, briefly outshining entire galaxies. Amid the chaos and energy of this cataclysm, new elements are forged, elements heavier than iron, like gold and uranium. And as the ejected material cools, dust begins to form. But this process is more violent and unpredictable than the gentle shedding of a red giant. The shockwaves and radiation from the explosion can destroy some of the forming dust, while other grains survive, enriched by the incredible energy of the supernova. The ones that endure are flung far and wide into the cold stretches between stars, where they can linger for billions of years. Supernova dust is among the most ancient and pristine material in the universe. Scientists studying meteorites that have fallen to Earth have found tiny pre-solar grains, dust particles older than the solar system itself, with isotopic signatures that match what we would expect from a supernova. These particles drifted through the galaxy for eons before being swept into the cloud that formed our sun and planets. And now, here on Earth, we can hold them in our hands. In some cases, entire nebulae, vast, glowing clouds, are formed from the remnants of dying stars. These are sometimes called planetary nebulae, even though they have nothing to do with planets. These clouds, rich in dust and gas, shine softly in the night sky. The dust within them will, over time, merge with other clouds, become part of new stars, new solar systems, and eventually, new planets. In this way, the death of a star becomes the beginning of something else. This cycle of birth and death is the heartbeat of the cosmos. Stars are not just brilliant points of light in the night sky, they are factories, crafting the elements of life and scattering them into space as they fade away. Cosmic dust is not just a byproduct of these deaths, it is the bridge between one generation of stars and the next. And even though these particles are unimaginably small, and the process of their creation occurs light years away, and over spans of time far beyond human life, their story touches us deeply. Because we are, quite literally, made of this dust. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it was forged in the heart of a star. And before it became part of you, it travelled through the universe as dust. So when you look up at the night sky and see the stars, know that they are not only lights, they are life givers. And when those stars die, they do not disappear. They become part of a quiet, drifting legacy. A cosmic whisper carried by dust. A reminder that from death comes life. That endings are not really endings. And that the universe, even in its most explosive moments, creates beauty that floats silently through space, waiting to begin again. Once cosmic dust is born in the fiery death of stars, it embarks on a journey that spans unimaginable distances, drifting silently through the vast, dark ocean of the interstellar medium. This journey is not fast, nor is it linear. It is slow, patient, and gentle. The particles float, carried by invisible forces through the emptiness between stars, weaving a delicate thread through the galaxy's quiet spaces. This phase of dust's existence is one of solitude and subtle transformation, where it can wander for millions, even billions of years before ever finding a new home. The interstellar medium, the space between stars, is not as empty as it appears to the human eye. Though it may seem like a black void, it's filled with tenuous clouds of gas, mostly hydrogen, and an ever-present sprinkling of dust. In fact, though cosmic dust makes up only about 1/1 of the mass in these regions, it plays an outsized role in shaping their structure and behaviour. The dust is like seasoning in a cosmic soup, small in quantity but crucial in character. As the dust moves through this medium, it interacts with many forces. One of the most important is radiation pressure, the gentle push of starlight. Every star emits light, and that light carries energy. When photons of light strike a dust particle, they exert a tiny pressure. Over time, the pressure can push the dust slowly through space, nudging it along its journey. Though the force is delicate, far too faint to be felt by anything large, it can have a profound effect on these microscopic travellers. Another important force at play is gravity. The gravity of nearby stars, planets, and molecular clouds can pull dust in, changing its path. Sometimes, dust particles are drawn into dense regions where new stars are forming. Other times they are flung outward by the swirling motion of galactic rotation. These gravitational tugs and pushes shape the great arms of spiral galaxies, where dust tends to collect in dark, curving lanes that you can see in images of galaxies like the Milky Way or Andromeda. But the interstellar medium is not a gentle place. It is filled with radiation, shock waves from distant supernovae, and fast-moving particles. Dust grains can be bombarded, eroded, or even destroyed by these harsh conditions. Some grains are shattered into even smaller pieces. Others accumulate icy coatings as they pass through colder regions, gradually transforming as they move from one zone of space to another. Despite these challenges, some dust survives, and as it travels, it often begins to clump together with other particles, forming small aggregates. Over time, these can become the seeds of larger structures, tiny clusters of matter that will someday help build planets, moons, and comets. But even when they don't join into something larger, individual dust particles still play an essential role in the cosmic environment. One of their most important contributions is to the process of cooling. Dust helps cool down the gas in interstellar clouds by radiating away heat as infrared light. This cooling is essential for star formation. Without it, gas would remain too warm and too diffuse to collapse under its own gravity. But with the help of dust, the gas can shed its energy, condense, and eventually form new stars. In this way, dust not only carries the legacy of dying stars, it enables the birth of new ones. Dust also affects how we see the universe. As it floats through space, it scatters and absorbs starlight. This can make distant stars appear redder and dimmer, a phenomenon called interstellar reddening. Entire regions of the sky can be obscured by thick clouds of dust, hiding stars and galaxies from view. But when observed in infrared wavelengths, where dust glows with its own gentle heat. These hidden regions are revealed as places of creation and mystery, some of the most beautiful objects in the sky, the glowing tendrils of emission nebulae, the soft shadows of dark clouds, the shimmering veils of reflection nebulae, owe their appearance to cosmic dust. The dust acts like a canvas upon which light is painted, scattering it in soft hues and shapes that drift silently across the heavens. These are not quick events. These are processes that unfold over thousands, even millions of years. Every flicker and glimmer in a dust cloud is the result of ancient movement, of particles that have journeyed across space for longer than all of human history. In the vast silence of the interstellar medium, time behaves differently. There are no days or nights, no seasons or minutes. There is only the long, drifting now. Dust grains may pass through entire regions of the galaxy, orbiting the galactic centre over hundreds of millions of years. They may witness the birth of stars from afar, or drift through lifeless voids where light rarely shines. And all the while, they remain suspended in the gentle balance of forces: light, gravity, motion, and stillness. Eventually, some of these particles will find their way into molecular clouds, dense, cold regions where gravity begins to take over. There, the dust may be drawn into the heart of a forming star system, caught up in spinning disks of material. It may be heated, melted, or reforged into something new. Or it may remain intact, becoming part of an asteroid or a comet, or perhaps, in time, part of a world. But before any of that can happen, the dust must travel. It must wander. It must pass through the long corridors of interstellar space, touched only by starlight and shadow. This is its time of solitude, a time of transformation, a slow, drifting pilgrimage between the stars. And so, the next time you gaze up into the night sky, remember that beyond the stars you see, in the dark spaces between them, there is something else, something ancient, something silent, tiny grains of dust, each carrying within them a memory of a star's final breath, each one moving ever so slowly through the infinite quiet. A journey with no sound, no hurry, and no end, only the soft rhythm of the cosmos, gently guiding them through the darkness. The Milky Way, our home galaxy, is a vast, magnificent spiral of stars, gas, and dust stretching across the cosmos. When we look up at the night sky on a clear evening far from city lights, we often see the bright, milky band arching overhead. This glowing band is the collective light of billions of distant stars. But woven through this light is something far more subtle and mysterious: cosmic dust. Though invisible to the naked eye in many cases, this dust shapes the very appearance and life of our galaxy. Within the Milky Way, cosmic dust is far from evenly spread. Instead, it gathers in intricate clouds and lanes, often tracing the elegant spiral arms that sweep across the galaxy. These dust lanes appear as dark, shadowy streaks blocking the starlight behind them, patches where the light of countless stars is dimmed or hidden altogether. When viewed through telescopes that detect visible light, these lanes can seem like gaps or holes in the starry glow, but in reality, they are filled with dense, cold dust and gas. The presence of dust in the Milky Way is essential for the ongoing cycle of creation and destruction that defines our galaxy. Dust plays a vital role in star formation, as it acts as a cooling agent that allows clouds of gas to collapse and form new stars. Without dust, the gas in these regions would remain too warm and diffuse to coalesce, and star formation would stall. In this sense, dust is both a veil and a womb, shrouding newborn stars in mystery while nurturing them as they grow. One of the most fascinating features of the Milky Way's dust is how it scatters and absorbs light. Dust grains, though tiny, are remarkably efficient at capturing and redirecting starlight. Blue light is scattered more than reds, which means that when starlight passes through dusty regions, the stars appear redder and dimmer, an effect known as interstellar reddening. This phenomenon is similar to the way our sunsets appear redder on Earth, as sunlight passes through more atmosphere and scatters blue wavelengths. The interaction between dust and light also means that the Milky Way is not just a bright band of stars, but a complex tapestry of light and shadow. In some areas, dust clouds glow faintly in infrared light, revealing hidden regions of starbirth. Infrared telescopes, such as the Spitzer Space Telescope or the James Webb Space Telescope, have allowed astronomers to peer through these dusty veils and uncover stunning new details about the life cycle of stars and planets. In addition to tracing the spiral arms, dust is found in dense molecular clouds, cold, massive clumps of gas and dust, where star formation happens most actively. These clouds, sometimes called stellar nurseries, are thick enough to block visible light entirely. The famous Orion Nebula, visible even to the naked eye from dark skies, is a perfect example. Its glow is shaped by both the stars within and the surrounding dust, creating a breathtaking blend of light and shadow. But the Milky Way's dust is not static. It is part of a dynamic, ever-changing system. Stars are constantly forming within dusty clouds, then later expelling material through stellar winds and supernova explosions, replenishing and enriching the dust with new elements. This cycle keeps the galaxy vibrant, continually renewing itself with fresh material for the next generation of stars and planets. On a larger scale, dust helps define the structure of the galaxy itself. The spiral arms of the Milky Way are made more visible by the concentration of dust and gas, which highlights these sweeping curves of star formation. These arms act like cosmic highways, guiding the flow of material and energy across the galaxy. Dust clouds within them can be hundreds of light years across, vast enough to cradle thousands of stars in various stages of life. Furthermore, dust influences the chemistry of the interstellar medium. The surfaces of dust grains provide a space where simple molecules can form and combine, leading to more complex organic compounds. These compounds, some of which may be the precursors to life, are then distributed across the galaxy, carried by the slow winds of stars or the explosive force of dying giants. Despite its crucial role, cosmic dust remains elusive. Most of it is too cold and too thinly spread to be seen in ordinary light. It whispers its presence through faint glows in infrared and radio waves, or by blocking and reddening starlight. But this quiet presence is a constant reminder of the galaxy's ongoing story, a story of matter cycling between stars and space, darkness and light. In many ways, cosmic dust in the Milky Way is a bridge between the vastness of space and the intimate processes of creation. It connects the death of old stars with the birth of new ones. It shapes the light that reaches our eyes and moulds the very structure of the galaxy we call home. And though these particles are tiny and fragile, together they form a cosmic fabric, soft, intricate, and endlessly fascinating. When you gaze up at the Milky Way on a clear night, remember that the band of light you see is not just stars shining alone. It is a living, breathing system of dust and gas, swirling in the galaxy's grand dance. Each shadow, each glow, tells a story of creation, transformation, and the quiet power of the smallest particles shaping the universe around us. Astronomers have long been fascinated by cosmic dust, yet studying these tiny, elusive particles presents unique challenges. Dust is minuscule, often no larger than a fraction of a micrometer, and scattered sparsely throughout the vastness of space. It doesn't emit much visible light on its own, and it often obscures the very objects astronomers wish to observe. Despite these difficulties, scientists have developed ingenious tools and techniques to unlock the secrets of cosmic dust and understand its essential role in the cosmos. One of the primary ways astronomers study dust is by observing how it interacts with light. Although dust particles themselves are too small to see directly in visible light, they affect starlight passing through or near them. Dust scatters and absorbs this light, creating shadows and reddening effects that can be detected with sensitive instruments. By carefully measuring the amount and wavelength of light lost or scattered, astronomers can infer the quantity, size, and composition of dust along the line of sight. Infrared astronomy has revolutionized our understanding of cosmic dust. Unlike visible light, which dust can block or scatter, infrared light penetrates dusty clouds more easily. Dust particles also absorb energy from nearby stars and re-emit it as faint infrared radiation. Using space telescopes equipped with infrared detectors, such as the Spitzer Space Telescope and the more recent James Webb Space Telescope, astronomers can peer into dense star-forming regions hidden behind thick veils of dust. These infrared observations reveal the shapes and structures of molecular clouds, the cocoons of newborn stars, and the intricate networks where dust collects. Radio telescopes also play a vital role. Certain molecules that form on the surfaces of dust grains emit radio waves at characteristic frequencies. By detecting these signals, astronomers can study the chemistry occurring within dusty regions and understand how simple molecules evolve into complex organic compounds, some of which may be the precursors of life. In addition to remote observations, direct collection of cosmic dust has provided invaluable insights. Space missions like NASA's Stardust spacecraft have ventured beyond Earth's atmosphere to capture dust particles from a comet's tail and interstellar space itself, using special collectors made of ultra-light aerogel, a substance resembling frozen smoke. Stardust gently trapped high-speed dust grains without damaging them. When these particles return to Earth, scientists examine them under powerful microscopes, revealing their mineral makeup, isotopic signatures, and tiny inclusions. This hands-on study helped confirm that some dust grains originated from ancient stars, while others were formed in the cold reaches of space. On Earth, meteorites that fall through the atmosphere also contain tiny dust grains embedded within them. By analysing these grains, scientists gain a window into the early solar system's dust and the processes that led to the formation of planets. These microscopic fossils reveal information about the temperatures, pressures, and chemical reactions that took place billions of years ago. Laboratory experiments on Earth complement astronomical observations. Scientists recreate the conditions of space, ultra-high vacuum, extreme cold, and radiation, and study how dust grains form, evolve, and interact with gases and light. These experiments help interpret data collected by telescopes and spacecraft, bridging the gap between observation and theory. Advances in computer simulations have added another dimension to dust research. By modelling the physics of dust particles, how they absorb and scatter light, how they stick together, and how they respond to forces like gravity and radiation pressure, astronomers can predict the behaviour of dust in various environments. These simulations guide observations and help interpret complex phenomena, such as the formation of planetary systems or the structure of dusty galaxies. Even amateur astronomers contribute to the study of cosmic dust in their own way. Observations of meteor showers, caused by Earth passing through streams of dust left by comets, provide data about the distribution and composition of dust in the solar system. By noting the timing, brightness, and frequency of meteors, enthusiasts help refine models of dust trails and their evolution. All these methods come together to create a rich and detailed picture of cosmic dust. We now know that dust is not simply a nuisance or background noise in astronomy, but a key player in the life cycle of stars and planets. It shapes the very fabric of galaxies, acts as a catalyst for chemical complexity, and carries the fingerprints of ancient stars across space and time. As technology continues to advance, new instruments and missions promise to deepen our understanding even further. Future telescopes will have greater sensitivity and resolution, allowing astronomers to study dust in distant galaxies and in environments never before accessible. Missions that return samples from comets, asteroids, or interstellar space may reveal new types of dust particles and unknown chemical compounds. In this way, the study of cosmic dust is a perfect blend of observation, experimentation, and exploration. It requires patience to catch these tiny particles drifting through the vastness of space, creativity to develop the tools needed to see the unseen, and imagination to interpret what they tell us about the universe. Each dust grain studied brings us closer to understanding how stars are born, how planets form, and ultimately, how life itself may arise. Through the eyes of astronomers and the delicate instruments they create, cosmic dust transforms from a seemingly insignificant speck into a storyteller of the cosmos, whispering the secrets of creation, transformation, and the endless dance of matter and light across the universe. Cosmic dust is not just a distant phenomenon confined to the far reaches of space. It is also something that intimately touches our planet every single day. While we often think of space as a remote, empty void, the reality is that Earth is constantly collecting tiny particles from beyond our atmosphere, microscopic grains of cosmic dust that gently drift down and settle on our world. This slow, steady rain of space dust connects us in a tangible way to the vast universe beyond. Each day, it is estimated that around 100 tons of cosmic dust and micrometeorites enter Earth's atmosphere. Though these particles are incredibly small, often just fractions of a millimetre in size, they arrive in such vast numbers that their combined mass adds up significantly. Unlike the spectacular meteors that blaze brightly as shooting stars, most of this dust is too small and fragile to create visible streaks in the sky. Instead, it falls quietly, invisibly, settling on land, oceans, and even into the air we breathe. As these dust grains enter the atmosphere, many burn up completely due to friction with the air, creating the tiny flashes of light we see during meteor showers. But the smallest particles survive this fiery passage, cooling as they fall and drifting down gently. Once on Earth's surface, these cosmic visitors mix with terrestrial dust and soil, becoming part of the planet's natural environment. Scientists have discovered cosmic dust in some surprising places. It has been found in the polar ice caps, preserved within layers of ice that have built up over thousands of years. In deep ocean sediments, tiny space grains settle slowly onto the seabed, becoming part of the sedimentary record. Even in deserts and remote mountain ranges, cosmic dust quietly accumulates, often unnoticed by those who live there. What makes cosmic dust particularly fascinating is that it carries clues about the universe beyond Earth. By collecting and studying these particles, scientists can learn about the composition of other celestial bodies and the processes occurring in distant star systems. Some dust grains originate from ancient stars or supernovae, carrying isotopic signatures that reveal their stellar origins. Others come from comets and asteroids within our own solar system, offering a glimpse into the early days of planetary formation. Cosmic dust also plays a subtle role in the Earth's atmosphere and environment. In some cases, dust particles act as nuclei around which water vapour condenses, influencing cloud formation and weather patterns. Though the effect of cosmic dust on Earth's climate is still a subject of research, it illustrates how interconnected our planet is with the cosmos. Meteorites, larger fragments of space debris, occasionally fall to Earth, attracting attention due to their size and rarity. But the smaller cosmic dust grains are far more numerous and form a continuous stream of extraterrestrial material entering our world. These tiny visitors remind us that Earth is not isolated. It is part of an ongoing cosmic exchange. Advanced collection techniques have allowed researchers to capture cosmic dust directly from the atmosphere. High-altitude aircraft and balloons equipped with special collectors gather dust particles floating in the stratosphere, above most of Earth's weather and pollution. These pristine samples help scientists study the true nature of cosmic dust without contamination from Earth-based materials. On the ground, researchers use ultra-clean laboratories to analyze cosmic dust under powerful electron microscopes. These analyses reveal astonishing complexity. Dust grains with crystalline structures, tiny cavities, and even traces of organic molecules. Some particles appear to have formed in the cold reaches of space, coated with ices and layered with compounds that may be precursors to the building blocks of life. The presence of cosmic dust on Earth is also a reminder of our planet's place in the vast solar system. We orbit within a cloud of dust and gas left over from the Sun's formation, passing through streams of particles shed by comets and asteroids. Occasionally, Earth crosses particularly dense dust trails, resulting in spectacular meteor showers visible from the surface. For billions of years, cosmic dust has fallen on Earth, long before humans existed. It has been part of the environment that shaped the earliest oceans and atmosphere. Some scientists speculate that dust particles carrying organic compounds may have contributed to the chemical precursors necessary for life's emergence on our planet. Though this idea remains a topic of active research, it underscores the deep connection between cosmic dust and the story of life itself. As you go about your day or rest beneath the night sky, consider the gentle rain of cosmic dust falling around you, silent, invisible, yet profoundly significant. Each speck is a tiny messenger from distant stars and ancient explosions, carrying the history of the universe. They remind us that Earth is not alone in the cosmos, but part of a vast, interconnected web of matter and energy. This quiet shower of stardust brings the universe a little closer, touching our world in the softest, most unassuming way. Cosmic dust is not merely a collection of tiny particles floating aimlessly through space. It is the very foundation upon which planets are built. The process by which dust transforms from minute grains into massive, complex worlds is a slow and delicate dance, spanning millions of years and involving countless interactions. To understand how dust helps create planets, we must begin by looking closely at the early stages of star and planet formation. When a cloud of gas and dust in space begins to collapse under its own gravity, a new star is born at its centre. Around this newborn star, the remaining material forms a swirling disk known as a protoplanetary disk. This disk is a rich, dynamic environment filled with gas and dust particles. It is within this vast, rotating pancake of cosmic material that planets begin their journey from dust to solid bodies. At first, dust grains within the disk move slowly, occasionally colliding with one another. These collisions are usually gentle, allowing grains to stick together through electrostatic forces, like tiny magnets attracting one another. Over time, these sticky particles form larger clumps, growing from microscopic sizes to pebbles, then to rocks. This gradual growth is called accretion, and it is the first crucial step in planet formation. As the clumps become bigger, their gravity starts to matter. Larger rocks attract smaller particles, pulling them in and growing further. This growth leads to the formation of kilometre-sized objects, known as planetesimals, the building blocks of planets. In some regions of the disk, planetesimals collide and merge, forming even larger bodies called protoplanets. This process is not uniform or simple. It is a chaotic environment where collisions can sometimes be destructive, breaking bodies apart, while in other cases, they lead to growth. Gas in the disk also plays a role, influencing the motion of dust and planetesimals, creating turbulence and helping some particles settle toward the disk's mid-plane where growth is more efficient. Dust grains are vital in this process because they provide the raw material. Without dust, there would be no solid matter to stick together. The composition of these grains, silicates, metals, carbon compounds and ices, determines the types of planets that can form. In the warmer inner regions of the disk, closer to the star, dust grains tend to be rocky and metallic, forming terrestrial planets like Earth and Mars. Farther out, where it is colder, dust can be coated with ices, allowing for the formation of gas giants and icy bodies. Dust also affects the temperature and chemistry of the disk. By absorbing and re-radiating energy, dust helps regulate the environment where planets form. It provides surfaces where chemical reactions occur, forming complex molecules that can become part of emerging planets. This chemical richness may have implications for the potential habitability of planets formed in these dusty disks. As protoplanets grow, they can clear gaps in the disk, gathering gas and dust, and shaping the disk's structure. Some dust is pushed outward, while other material spirals inward, feeding the young star. Observations of protoplanetary disks around distant stars reveal rings and gaps that hint at planets forming amidst the dust. Eventually, protoplanets become full-fledged planets, clearing their orbits of remaining dust and gas. What was once an invisible cloud of microscopic grains has transformed into a complex system of worlds, moons, asteroids, and comets. But even after planet formation, dust continues to play a role. Collisions between asteroids and comets generate dust that creates debris disks around mature stars, while dust settling on planetary surfaces can influence atmospheres and climates. The entire journey from dust to planet is a testament to the power of tiny things working together over vast timescales. It is a slow, patient process where countless particles, almost invisible alone, combine to form the foundations of a world capable of harbouring life. Reflecting on this, it is humbling to realise that the ground beneath our feet, the rocks and soil, even the very molecules in our bodies, all began as specks of cosmic dust swirling around a young star long ago. These specks drifted, collided, and clung together until they formed the Earth itself. So the next time you gaze up at the night sky, remember that every planet you see started with dust, soft, fragile, and seemingly insignificant, yet with the extraordinary power to create entire worlds. Cosmic dust is more than space debris. It is the universe's building block, quietly shaping the architecture of the cosmos and giving rise to the places we call home. Cosmic dust plays a profound role in creating some of the most breathtaking and mysterious objects in the night sky, nebulae. These immense clouds of gas and dust are not only visually stunning, often appearing as vibrant, glowing clouds or dark, shadowy silhouettes against a backdrop of stars, but they also serve as the very cradles of starbirth and the graveyards of dying stars. Nebulae owe much of their beauty and complexity to the presence of dust, which shapes light, colour, and form in ways both subtle and spectacular. When we think of nebulae, we often picture luminous clouds painted in hues of red, pink, blue, and green, images captured by powerful telescopes that reveal glowing gases and intricate filaments. However, underlying this radiant display is a complex interplay between dust and gas. Dust particles, though tiny and almost invisible on their own, act as both a canvas and a filter for the light emitted by ionized gases within the nebula. One of the key types of nebulae influenced by dust is the emission nebula. These glowing clouds are energized by the intense ultraviolet light from nearby young, hot stars. This light excites the gas, causing it to emit light in various colors, most notably the reddish glow of hydrogen atoms. Dust mixed within these regions absorbs and scatters some of the light, softening the glow and creating delicate shadows and highlights. This interplay gives emission nebulae their textured, three-dimensional appearance, where light and shadow seem to dance across cosmic clouds. Dust also contributes to the formation of reflection nebulae, which do not glow on their own, but shine by reflecting the light of nearby stars. Dust grains scatter the starlight, often preferentially scattering blue light more than red, which is why reflection nebulae commonly appear blue and ethereal. The famous Pleiades star cluster, surrounded by such a nebula, is a beautiful example of dust revealing the hidden presence of star-forming material through reflected light. Perhaps the most dramatic effect of dust is seen in dark nebulae, also called absorption nebulae. These are dense, cold clouds of dust and gas so thick that they block the light from stars and glowing gas behind them, appearing as dark patches or silhouettes against the brighter regions of the Milky Way or other nebula. The Horsehead Nebula, one of the most iconic dark nebulae, is a striking example. Its dense dust cloud shapes a distinct horse-like shadow in front of a glowing background. These dark nebulae are often stellar nurseries, regions where dust and gas are collapsing under gravity to form new stars, yet their thick dust veils conceal this activity from ordinary visible light. Dust's role in nebulae goes beyond shaping appearances. It also plays a crucial part in the chemistry and physics of these clouds. Dust grains provide surfaces for atoms and simple molecules to stick to and react on, facilitating the formation of more complex molecules such as water, ammonia, and organic compounds. These molecules are fundamental to the chemistry of star-forming regions and may eventually seed newly forming planets with the ingredients for life. As stars form within nebulae, their intense radiation and stellar winds begin to sculpt the surrounding dust clouds, carving out cavities and shaping pillars and filaments. The famous pillars of creation within the Eagle Nebula are towering columns of dust and gas, sculpted by the radiation from young, massive stars nearby. These pillars are incubators of new stars, hidden within dense knots of dust that shield them from harsh radiation until they are ready to emerge. Nebulae also represent a bridge between the death of stars and the birth of new ones. When massive stars reach the end of their lives in supernova explosions, they expel vast amounts of material, including dust, into space. This material enriches the interstellar medium, contributing to the next generation of nebulae and star formation. The Crab Nebula is a famous remnant of such a supernova, where dust and gas continue to expand and interact, glowing from the energy left behind. Over time, dust in nebulae can clump together and grow, eventually becoming part of the dense cores that collapse into new stars and planetary systems. This process connects the life cycle of dust and stars in an endless cosmic loop, where the material that once formed distant suns returns again and again to create new worlds. The intricate shapes and colours of nebulae, so captivating to astronomers and stargazers alike, are thus intimately linked to the presence and properties of cosmic dust. Without dust, the soft shadows, shimmering reflections, and rich colours of these celestial clouds would not exist. Instead, the universe would lose some of its most spectacular and poetic displays. In quiet moments beneath the night sky, when you look up and see the faint, glowing patches or dark smudges of nebulae, remember that these are more than just clouds of gas. They are vibrant, living tapestries woven from dust and light. Each dust grain contributes to the grand artistry of the cosmos, helping to shape the nursery where stars and planets are born, and telling a story of transformation, beauty, and endless renewal. Around many young stars, vast disks of dust and gas swirl in graceful, expansive rings, silent nurseries where new worlds begin to take shape, These dusty disks, often called protoplanetary or circumstellar disks, are some of the most fascinating environments in the cosmos, offering a glimpse into the very earliest stages of planetary formation. Although invisible to the naked eye, their presence is revealed through the glow of dust, warmed by starlight, and the subtle shadows they cast across space. When a star forms from the collapse of a dense cloud of gas and dust, the remaining material doesn't simply vanish. Instead, it settles into a rotating disk encircling the newborn star, shaped by the laws of physics and the conservation of angular momentum. These disks can stretch from just a few astronomical units, the distance from Earth to the Sun, to hundreds of times that distance, containing a mixture of gas, mostly hydrogen and helium, and solid particles of dust. The dust grains within these disks are tiny but crucial. They absorb and scatter light from the central star, heating up just enough to emit infrared radiation, which telescopes can detect. Observations using powerful instruments such as the Atacama Large Millimeter Submillimeter Array, LMA, and the Hubble Space Telescope have provided remarkable images of these disks, revealing stunning rings, gaps, and swirling patterns. These structures hint at dynamic processes at work, possibly shaped by the formation of planets within the disk. When a planet begins to grow, its gravity can carve out gaps or create waves in the surrounding dust, like a boat making ripples in a calm lake. Dust within these disks is not uniform. The tiny particles now range from microscopic grains to larger pebbles, and their composition varies depending on their distance from the star and the local environment. Closer to the star, where temperatures are higher, volatile ices evaporate, leaving behind rocky and metallic grains. Farther out, cooler temperatures allow ices, water, methane, ammonia, to coat the dust grains, creating fluffy, icy aggregates. This variation sets the stage for different types of planets to form: rocky terrestrial planets near the star, and gas giants or icy bodies farther away. The dust grains themselves begin a slow but vital process of growth. Through gentle collisions, they stick together, forming larger clumps that eventually become planetesimals, the seeds of planets. This aggregation is not a smooth or guaranteed process. Collisions can sometimes break particles apart, and the disk environment is turbulent. Still, over millions of years, dust particles grow and settle toward the mid-plane of the disk, forming a dense, thin layer where planet formation becomes more efficient. As the dust evolves, chemical reactions on the surfaces of grains produce complex molecules, including organic compounds that are the building blocks of life. These molecules become part of the material incorporated into growing planets and comets, seeding them with potential precursors to biological chemistry. This cosmic chemistry happening within dusty disks links the story of star and planet formation to the origins of life itself. The dust disks around young stars are also transient phenomena. Over time, stellar winds, radiation pressure, and interactions with forming planets disperse the gas and dust. After a few million years, much of the disk material either accretes onto the star or is blown away, leaving behind a planetary system, and often a thinner, debris disk composed of leftover dust from collisions between asteroids and comets. Studying these disks is not only a window into how our own solar system formed billions of years ago, but also a way to understand the incredible diversity of planetary systems in the universe. Each disk presents unique features shaped by its star's mass, age, and environment, offering clues about the variety of planets that might emerge. Thanks to advancements in technology, astronomers have identified numerous young stars surrounded by these dusty disks across our galaxy. Each observation adds to our knowledge of the complex processes that transform humble dust grains into majestic planets. These findings inspire awe and wonder, reminding us that the world we see, and those yet unseen, began as mere specks of dust orbiting distant stars. So when you imagine the sparkling stars overhead, consider that many of them are cradling swirling disks of dust, cosmic workshops quietly at work. Within these disks, dust dances and gathers, slowly building the foundations of new worlds. From these silent, swirling rings emerge the planets that may one day harbour life, telling a story as old as the universe itself. Cosmic dust may seem like mere specks scattered through space, but it carries within it one of the most intriguing possibilities in the story of life in the universe. The idea that dust grains might harbour the very building blocks of life itself. For decades, scientists have pondered how the complex organic molecules necessary for life could have formed and spread throughout the cosmos. The answer may lie, in part, on the tiny surfaces of cosmic dust particles drifting through the cold vastness of space. In the cold reaches between stars, where temperatures plunge to just a few degrees above absolute zero, dust grains provide a unique environment. These microscopic particles, composed of silicates, carbon, ices, and metals, act as tiny cosmic laboratories. Their surfaces allow atoms and simple molecules to stick and interact in ways that would be impossible in the gas phase alone. On these dust grains, chemical reactions can proceed slowly but steadily, leading to the formation of complex organic molecules. Observations with radio and infrared telescopes have revealed that molecular clouds, dense regions of gas and dust where stars form, are rich in a variety of organic molecules. Some of these molecules are surprisingly complex, including amino acids and precursors to sugars, which are essential components of life as we know it. The dust grains act as catalytic surfaces, helping to assemble these molecules in the cold darkness where liquid water cannot exist. One fascinating aspect is how dust grains accumulate icy mantles made of water, methane, ammonia, and other simple molecules. These icy coatings serve as both protective shelters and reactive environments. When exposed to ultraviolet radiation from nearby stars or cosmic rays, the molecules within the ice can break apart and rearrange, forming new, more complex compounds. Laboratory experiments simulating these conditions have produced amino acids and other organic molecules on dust analogues, supporting the idea that space dust is a crucible of chemical complexity. The presence of these complex organics in space dust raises profound questions about the origins of life. If these molecules form widely throughout the galaxy, they could be delivered to planets during their formation or via comets and meteorites long after planets have formed. This cosmic delivery system might have provided the essential ingredients that jump-started prebiotic chemistry on early Earth and possibly other worlds. Meteorites found on Earth provide concrete evidence for this idea. Many carbonaceous chondrites, primitive meteorites rich in carbon, contain a variety of organic compounds, some of which likely originated in space before being incorporated into the early solar system. These meteorites carry tiny dust grains with isotopic signatures pointing to interstellar origins, linking the chemistry of cosmic dust directly to material that found its way to our planet. Furthermore, comets, often described as dirty snowballs, are rich reservoirs of dust and ices laden with organic molecules. When comets approach the Sun, they release this material, potentially delivering organics to planetary surfaces. This supports the notion that cosmic dust acts as a carrier, ferrying life's building blocks across vast distances and timescales. The implications extend beyond our solar system. If dust grains throughout the galaxy routinely host complex organic chemistry, then the ingredients for life may be widespread. Planets forming in dusty disks around other stars might receive a similar cosmic gift, increasing the likelihood that life could emerge elsewhere. Research into cosmic dust's role in astrochemistry continues to grow, blending astronomy, chemistry, and biology into an interdisciplinary quest. Instruments like the James Webb Space Telescope are expected to deepen our understanding by detecting organic molecules in distant star-forming regions and planetary systems. Meanwhile, laboratory studies on Earth continue to simulate the conditions of space, exploring how life's precursors can assemble on dust. At its core, the story of cosmic dust and life's building blocks is one of connection, tiny grains bridging the vast emptiness of space and the complexity of living organisms. These particles are silent couriers of chemistry, moving through the universe for billions of years, carrying the seeds of possibility. So, as you gaze at the stars, consider that drifting invisibly among them are dust grains rich with organic molecules, waiting to be delivered to new worlds. Within these specks may lie the origins of life itself, a cosmic thread weaving through the fabric of the universe, connecting stars, planets, and perhaps living beings like us. The humble dust grain is more than space debris. It is a messenger of life's potential, quietly journeying across the cosmos. Every night, countless tiny visitors from space streak across our sky, captivating our imagination as shooting stars or meteors. What many don't realize is that these dazzling streaks of light are often caused by cosmic dust, microscopic particles that, despite their small size, create a spectacular show as they enter Earth's atmosphere. This fiery phenomenon connects us directly to the cosmic dust that drifts silently through the solar system, revealing an ancient journey from distant space to our night sky. As cosmic dust travels through space, it orbits the Sun along with planets, moons, asteroids, and comets. Occasionally, Earth passes through clouds or streams of dust left behind by comets, or scattered debris from asteroids. When these tiny particles collide with our atmosphere at high speeds, sometimes tens of kilometers per second, they encounter intense friction with air molecules. This friction heats the particles to extreme temperatures, causing them to glow brightly and vaporize almost instantly. The result is a brilliant streak of light that we see as a meteor. Though meteors can range in size from small grains to larger pebbles, the majority of these fiery streaks are caused by dust-sized particles, often no bigger than a grain of sand. Despite their minuscule size, their velocity generates enough heat to create a glowing plasma trail visible for a fleeting moment. This momentary flash connects us to the vastness of space. as these tiny specks originate from far beyond Earth. The glowing meteor trails often appear during meteor showers, which occur when Earth crosses particularly dense dust trails left by comets. Famous showers like the Perseids in August or the Geminids in December paint the night sky with numerous bright meteors, each caused by dust particles entering the atmosphere. These events provide a vivid reminder of the constant exchange between Earth and the cosmic dust environment. Once these dust particles enter the atmosphere, most burn up completely. However, some larger micrometeorites survive the intense heat and fall gently to the ground, becoming part of Earth's collection of extraterrestrial material. These surviving fragments carry valuable information about the composition of cosmic dust and its origins, helping scientists understand the makeup of comets, asteroids, and the early solar system. The fiery journey of cosmic dust through Earth's atmosphere also has subtle effects on our environment. The ablation, the vaporization and fragmentation of dust particles adds trace amounts of metals like iron, magnesium, and nickel to the upper atmosphere. These metals can influence atmospheric chemistry and contribute to phenomena such as noctilucent clouds, delicate ice clouds visible in twilight that reflect sunlight high above Earth. While meteors are often thought of as spectacular but rare events, cosmic dust impacts Earth continuously, day and night. Though individual particles are invisible to us in daylight, their cumulative effect shapes our atmosphere and adds to the steady rain of material falling onto the planet. Beyond Earth, meteoric dust also plays a role in other planetary atmospheres. Mars, for instance, experiences similar dust influxes, which may influence its thin atmosphere and surface chemistry. Even the Moon, lacking a substantial atmosphere, is continuously bombarded by micrometeorites, which slowly erode its surface and contribute to the fine layer of lunar dust known as regolith. The study of meteors and the dust that causes them bridges observational astronomy, atmospheric science, and planetary geology. Scientists use radar, optical cameras, and even satellite instruments to track meteors, analyze their trajectories, and estimate the amount and composition of incoming dust. These observations improve our understanding of the solar system's dust environment and its interactions with planets. In the grand scheme, the fleeting flash of a meteor is more than a beautiful moment in the night sky. It is the visible manifestation of cosmic dust's journey through space and time, a tiny traveller blazing briefly as it makes its final passage into our world. Each shooting star reminds us that Earth is not isolated but constantly connected to the universe around it, receiving the silent gifts of dust that have journeyed billions of miles. So next time you spot a shooting star, pause for a moment. Think about that tiny grain of cosmic dust, formed in the heart of a distant star, or shed by a comet long ago, now burning brightly in Earth's atmosphere for just a moment. It is a cosmic visitor, a messenger from the depths of space, offering a fleeting glimpse into the vast and beautiful story of the universe. Stories of cosmic dust have long captured human imagination, not only in the realm of science, but also in the colourful worlds of science fiction. Writers and creators have envisioned dust as more than just inert particles. They have transformed it into powerful symbols, mysterious forces, or even vehicles for advanced technologies. In many sci-fi tales, cosmic dust becomes a catalyst for adventure, discovery, and sometimes danger, illustrating our deep fascination with these tiny yet profound elements of the cosmos. Science fiction often portrays cosmic dust as a kind of cosmic glue or magic dust that can alter reality, enhance technology, or unlock hidden knowledge. For example, some stories imagine dust particles carrying alien microorganisms or nanobots that can infect or enhance life on planets, blurring the line between biology and technology. Others depict vast clouds of dust as dangerous hazards to spacecraft, capable of disabling entire fleets or serving as battlegrounds for interstellar conflict. In more poetic or philosophical works, cosmic dust symbolizes the interconnectedness of all things. The idea that every particle, no matter how small, is part of a greater cosmic tapestry. Dust becomes a metaphor for the origins of life, the fragility of existence, or the eternal cycle of birth, death, and rebirth in the universe. This symbolism resonates deeply, reflecting humanity's search for meaning in the vastness of space. Beyond fiction, cosmic dust inspires art, music, and visual storytelling, with its ethereal presence evoking wonder and mystery. Artists use images of swirling dust clouds, glowing nebula, and star-forming regions to evoke emotions of awe and curiosity, reminding us of our place in the cosmos. These cultural expressions show how cosmic dust transcends scientific study, entering the realm of human experience and creativity. Turning from imagination to reality, cosmic dust also serves as a bridge to ancient cosmic history. Some dust grains floating through space are truly ancient, older than our solar system itself. These tiny messengers have travelled for billions of years, carrying within them a record of conditions in the early universe. Scientists call these particles pre-solar grains because they formed before the birth of our sun. These ancient dust grains are often found embedded within meteorites that fall to Earth. Their isotopic compositions differ markedly from materials formed in our solar system, indicating origins in distant stars or supernova explosions that predate our sun by eons. By studying these grains, scientists unlock secrets about stellar processes, the chemical evolution of galaxies, and the timeline of cosmic events that shaped our universe. The idea that some dust is older than the planets, the Earth, and even our Sun invites profound reflection. These particles have witnessed the birth of galaxies, the death of stars, and the assembly of solar systems. Their journeys span space and time on scales that dwarf human lifetimes and civilizations. Holding such a grain in a laboratory is like touching a fragment of cosmic memory, a tangible connection to the ancient past. This ancient dust reminds us that the universe is not static, but a dynamic, evolving entity. The matter around us has been recycled countless times, born in stars, expelled in explosions, drifting through interstellar space, and finally gathered together to form new worlds. The dust is a symbol of continuity, resilience, and transformation, silently tracing the path of cosmic history. Finally, cosmic dust invites us into the peaceful silence of the universe, the quiet spaces between stars where time seems to slow, and matter drifts unhurriedly through the vast darkness. Unlike the violent births and deaths of stars, dust moves with gentle grace, carried by subtle forces like radiation pressure and gravity. Its slow, patient journey through space embodies a kind of cosmic stillness. In this silence, dust grains drift for millions or billions of years, barely touched by anything but starlight. They float in the cold interstellar medium, invisible to the naked eye, yet crucial to the fabric of the cosmos. Their presence shapes the light we see from distant galaxies and governs the birthplaces of stars and planets. This quiet existence also reminds us of the vast scales of space and time, where moments of human history are but fleeting blips. The dust's slow voyage through space is a meditation on patience, persistence, and the hidden beauty of things often overlooked. It teaches us that even the smallest particles have their place and purpose in the grand cosmic story. As we gaze up at the night sky, the gentle glow of distant stars and nebulae is softened and shaped by cosmic dust. It connects the bright points of light, fills the spaces between, and offers a silent invitation to contemplate the mysteries of the universe. In its calm and quiet way, cosmic dust beckons us to listen, to wonder, and to find peace in the vastness beyond.